Hello, welcome to my second class of Conceptual Organic Chemistry. It was a series class. In my first class, I taught you aldehyde, carboxylic acid and ketone, and out of this I just touched on the small unit of carboxylic acid. First of all, I convey my thanks to all the students, those who recommended a lots of valuable advice for rectifying the lots of defects in my class. Those are technical defects or defects, other defects. Today, I am going to tell you the second part of carboxylic acid, the chapter carboxylic acid. So let me first brush up the things which I taught in my first class. In my first class, that was CH2OH on strong in presence of strong oxidizing agent KMnO4, it gives compound along with COOH and CN-nitrile groups converts on acid hydrolysis at COOH. CONH2 converts to COOH on acid hydrolysis. Alkyl halide except 3-degree alkyl halide with benzene gives benzoic acid, that is alkyl parts converts to COOH. CH2OH same as KMnO4 alkaline conditions. Jones reagent make the same effect COOH. First of all, I want to tell you that to become a good student on organic chemistry or chemistry, you must have knowledge on GOC. It is very important. GOC must be at your hand. First of all. Second thing is, you should know a bit mechanism. Without mechanism, you can do nothing. And third one, you must have profound knowledge on the reagent above the error. That reagent may be reducing agent, may be oxidizing agent, may be type of reducing oxidizing agent, may be strong, mild, like this, and Jones, a lots of things are this. Fenton reagents, a lot of reagents. If you know the action or function of these reagents, at least you can imagine what product we are going to get from the reactant. Okay, so out of this concept, let me start some example from text. Let us try this. First of all, there was a conversion of butane 1-ol to butanoic acid. Butane 1-ol, CH3, CH2, CH2, CH2OH to butanoic acid. So it is very simple. It is very simple because at the very beginning, when I brushed up the last class, I told you CH2OH. I wrote a bit earlier here. CH2OH transformed into COOH with the help of Jones reagent. So that can very easily be converted into carboxylic acid with the help of Jones reagent. H2SO4 dilute in acetone that groups. Very simple. If you know you have the idea, you can very easily do. CH3, CH2, CH2, COOH. Butane 1-ol has now been converted into butanic acid in presence of Jones reagent. The second question is given as benzyl alcohol to benzoic acid. First, you draw the structure and then you will think how to convert. This is benzyl alcohol. Benzoic acid. I'm sorry, it was not benzyl alcohol. Benzyl alcohol to, not benzoic acid, benzyl alcohol to phenyl ethanoic acid. Phenyl ethanoic acid. That is benzyl alcohol this is the conversion. Benzyl alcohol to phenyl ethanoic acid. So you see, there is CH2OH and there is CH2COOH. If you just convert this into COOH by Jones reagent, it will just become COOH. So benzene COOH, you will get benzoic acid, you will not get CH2COOH. Phenyl ethanoic acid, you will not get, you will get it only this. If you just think to convert it into COOH by Jones reagent, you convert in this way. So we will not follow this process. We'll do one thing. First, we'll replace OH by Br. CH2Br. Then we'll replace Br by Kcn. We'll make react of this reagent with Kcn. Then this will be replaced by this. So now you have already known that CN group on acid hydrolysis. I had written earlier that CN on acid hydrolysis becomes COOH. Now this concept will come indeed. On acid hydrolysis, CH2 remains CH2 and CN will become COOH. This is second conversion. Third one is Three-nitrobromobenzene to 3-nitrobenzoic acid. 3-nitrobenzoic acid. 3-nitrobenzoic acid. Nitro in place of nitro, benzoic acid, COOH. So one thing you see, 3-nitrobenzoic acid, 3-nitrobromobenzene to 3-nitrobenzoic acid. We have seen nitro is in its position nitro. There is bromine in place of bromine, COOH. You can't convert it directly. You can't convert. So when there is a bromine, instantly there is a question. You try to make it Grignard reagent. That class I told you Grignard reagent. RMgX. X may be bromine, may be chlorine. When there is bromine, you try to make it Grignard reagent. So our step will be, we'll just give magnesium in dry ether, we'll get MgBr. In my last class, I told you Grignard reagent, you recall it, RMg plus carbon dioxide give you carboxylic acid. If you can't recall it, once again I will show you how it comes. So when you get Grignard reagent, forget about this. RMgX, phenyl, in our place of R it is phenyl. That MgX, it is Grignard reagent. So in this Grignard reagent, we will use carbon dioxide. So this is partially minus and this is partially plus. So you add up this here. This is Grignard. You write O double bond C O negative. In place of O, this is plus and this is minus. I told you in this way. Carbon part is minus, magnesium metal part is plus. And mind that effect is reversal of polarity. That is Ampolang effect. Here just one new term you have got Ampolang effect. Here Grignard reagent where CH3NgBr say it is plus and it is minus, so it is unexpected. So this is the concept of Claisen condensation. It is a bit high class in higher classes. Polarity has been reversed and that is Ampolang effect. You keep it in your mind. You make carbon negative and magnesium positive. Later on, if I get chance, I will tell you what is Ampolang effect. So here O double bond C O, in place of this O is minus, M part will come as this, and in this benzene part will come. Okay. Now make acid hydrolysis. H plus O is negative. So it will take H plus O negative. You make it here plus and O is minus. You are getting this into C double bond OH. So in this you are getting in this way. This is your dessert product. It is a bit hard. Just whenever you will get bromine alkyl part, you try to make it RMG or phenyl alkyl bromide, and then you go to carbon dioxide. You know it. Grignard reagent plus carbon dioxide give you carboxylic acid. Next is 4-methyl acetophenone. Methyl acetophenone to benzene 1,4-dicarboxylic acid. Benzene 1,4-dicarboxylic acid. Benzene 1,4-dicarboxylic acid. One 4-dicarboxylic. This is very simple. You know alkyl part on oxidation converts into this. So make oxidation. This you get this one, and on oxidation of this will get this one. Just you oxidize it, KMnO4. First of all, you will get this, and again you acid hydrolyze. Then in place of K you will get COOH. Very simple one. You target this on oxidation and this on oxidation comes. Next one is a bit hard. I will explain it a bit later on. I am showing you the process. Cyclobutene. I can write for time. I am not writing. It is cyclobutene. Cyclobutene to benzene 1,4 dicarboxylic acid, and its another name is adipic acid. So cyclobutene to benzene 1,4 dicarboxylic acid. You can't imagine how we can convert these to adipic acid. 1,4 dicarbenzene. It is not 1,4. Adipic acid is hexene benzene. Not benzene, it is hexene. 1,6-dicarboxylic acid. Adipic acid means it is open chain compound and it is cyclic compound. So we need to break this here. So I don't know have you got this reaction or not earlier, but there is a reaction that is RCH double bond CHR dash sec. If you oxidize this KMnO4 like this, nascent oxygen comes, so that breaks into two double bond, and in one part it comes RCHO. In other part it gets RCHO. So you are getting two aldehydes. Aldehyde very easily undergo another oxidation. Simultaneously COHO becomes COOH. Further it goes RCOOH, and that converts into RCOOH. So out of this you are getting, if it is R dash anything, RCOOH finally, and R dash COOH. That depends again upon that hydrogen. If there is no hydrogen, that part will be ketone. In place of hydrogen, if it is another R, so that part will be ketone, and that ketone will not undergo further oxidation. But if there is H, this is aldehyde, instantly it will undergo oxidation. So carboxylic acid comes depending upon H and H. If there is no H, this will be ketone. If there is H, this will be aldehyde and simultaneously carboxylic acid. Okay, so this is the background explanation. So what's happened if we use strong oxidizing agent with the help of nascent KMnO4, we will get nascent hydrogen oxygen, and that breaks here. So we get the reaction as like this. Earlier I have shown you on double bond it breaks into two parts. If there is a hydrogen, that becomes CHO, and on further oxidation it undergoes COOH, because there is CH double bond CH. Am I right? That's why there is H is there. First oxidation CHO, second oxidation COOH. First oxidation second part CHO, on initial final oxidation COOH. It is hexane 1,6-dicarboxylic acid or adipic acid. So this is, I think, a new. You please keep it in your mind. Double bond breaks on oxidation with strong oxidizing agent in presence of nascent oxygen. Next one is butanol. I think butanol to butanoic acid. Butanol, CH3, CH2, CH2, CHO, CH3, CH2, CH2, COOH. It is very simple. In my last class, I have not written anything, but I told you that there are some mild oxidizing agent, and out of this mild oxidizing agent, important mild oxidizing agents is tolerance reagent and Felix reagent, ammonium silver nitrate solution, or AgNH3 whole thing to OH negative. This is in short the formula of ammonium silver nitrate solution, tolerance reagent. This is mild oxidizing agent, and it is very easily oxidize CO group to COOH groups. So we will just use tolerance reagent, or you write ammonium silver nitrate solution. Okay, so we are getting in one step the result. Okay, so these are not important, not critical and tough. These simple things, just to keep it in your mind, whatever I taught you in my lesson. Today the new things I am going to start is the reactivity. Very important, you minutely follow. If you don't know the rule or where to convert, you will never able to understand the reaction, and it is impossible for you to keep all this organization in your mind. These things are very simple. All these things abide by the rules. You just shouldn't follow the objective type of questions or see the answer A and B, C, go on solving these things. It is not the way to learn organic chemistry. It is the things you should have grip on the background of GOC and some of the mechanism and profound knowledge of reagent which are written on the arrow. Okay, so on reactivity, I am just operating the whole carboxylic compound as some group. You minutely follow. Then all the carboxylic acid reactions will be in your hand. I am sure you can. You can do each and every type of question rising from your state to NWT, JEE, IIT, whatever you want. These are the strong background. If you can understand, you can do each and everything. It's my assurance. First of all, you see, we will concern with that H. First type of reaction involving H. First type of reaction involving H. Second type of reaction involving OH. Third type of reaction involving CO group. Here I will tell you something. Just to keep it in your mind, CO group. You are getting 1, 2, 3. 3 types. Next, involving with COOH group. It is 4th type of reaction. 5th type of reaction is reaction involving with this part, alkyl part. 6th type of reaction is, if it is aryl, then there is ring substitution type of reaction. Basically in carboxylic, these are the reactions. So I asterisk 1 point, gave asterisk marks to 1 point, RC double bond OH. When I talk about these, this carbonyl group is not the same of as aldehyde or ketone. Mind that. Where in aldehyde and ketone we have seen there is, I will explain it later on, nucleophilic addition type of reaction, this bond is withdrawn, this become plus, this become minus, nucleophile attacks here and adds up. Okay, here due to resonance, when it goes up, that's occur resonance. That double bond does not remain fixed on any carbon. It goes on rotating. That is resonance. So exactly CO in carboxylic groups is not functioning as CO in aldehyde and ketone because of the resonance in CO group. Mind that till I have written a type of reaction for your clear convenience occurs through that CO group only. So first of all, I am trying to make the reaction. You just learn stepwise. You can keep each and everything in your mind, otherwise you can't. We'll be concerned with that hydrogen. That type of reaction is what? Say I am taking one example, CH3, C double bond OH. In one step I will do. If I give sodium, that will give, my reaction is CH3, C double bond OH. We are concerning with that hydrogen only. So that hydrogen will change into CH3, C double bond ONA, and there is hydrogen. Am I right? If I place here sodium hydroxide, same reaction occurs, but the product will be this. Am I right? And now the third one is very important one. You see and follow me minutely. Sodium hydrogen carbonate. Again, the product, main product is the same, but here we are getting carbon dioxide, and there is brisk effervescence of carbon dioxide when carboxylic acid reacts with sodium hydrogen carbonate due to evaporation of carbon dioxide. This reaction is important for distinctions of phenol and carboxylic acid, because phenol is acid and carboxylic acid. Though carboxylic acid is more stronger than phenol, yet phenol reacts with sodium hydrogen carbonate, and if you assume, and carboxylic acid reacts with sodium carbonate reaction. But in case of sodium carbonate reaction with carboxylic acid, there is big effervescence of carbon dioxide, and that indicates the starting material or the compound is carboxylic acids, whereas no such carbon dioxide evolution is possible in when it is made to react with phenol. So that's why with the help of sodium hydrogen carbonate we can make distinctions of carboxylic acid with phenol. So first type of the reaction is over. Now what is second type of? Second type of reaction is CH3, C double bond OH. Will be concerned with OH. Again, these are the very simple. It is not of important, very much of important, but these things are very important for the reason that there are some conversion of the reactions, or in the exams there are some questions are being put, and some PCl3, PCl5, SOCl2, etc. are given on the arrow. So just to follow me, you can understand. This is not hard, very simple. You shouldn't learn at all just if you can understand at present. We are concerned with that OH. Am I right? So if you give PCl5, if you give PCl3, not all these things alone, individually. That too. So in all cases you are getting CH3, C double bond O. This. Here you are getting POCl3, and lots of side products are there. I will be concerned with if I make to react this compound with individually this you are getting this, individually this you are getting this, individually with this we are getting this along with sulfur dioxide and HCl. You have got the very important reaction where that product is very pure, where sulfur dioxide and hydrochloric acid goes up. There is no purification is necessary. That's why that reaction is thionyl chloride reaction is important. So this is first type. First type of the reaction where carboxylic acid involves with OH groups. Now, first type is over. What is second type? Second type of the reaction is esterification. It is very important. A lots of question appears in exam, either in entrance or in your board exam. Esterification. Esterification means what? Ester group will be introduced in the final compound, and generally here we will do the reaction will be proceed through acid, concentrated sulfuric acid. So what's happened here is we are dealing with CH3 C double bond OH carboxylic acid, and we are dealing with this group involvement. Am I right? So this carboxylic acid, and we are writing here an alcohol. We are giving an alcohol. It is a reversible reaction, concentrated H2SO4 or H plus. Since the technique, you just follow the technique. Since we are dealing with carboxylic acid and the reaction of the second type reactions where OH is involved, and we are talking about the esterification of the reaction, naturally the OH of carboxylic acid will be involved. Don't use this OH, you use this OH and H. You eliminate this water molecule, what you are getting is CH3 C double bond O, and here OC2H5. Introduction of C double O means OH ester group in the final product along with water. Thus this process is called esterification. Now one point here is most important is that in esterification, if you want to get more and more ester, these are very important things. Sweet smelling compounds are called esters. Am I right? And lots of important things can be synthesized out of this. Okay. So if you want think of the productions of more and more ester, so we need to do two things. One thing is our equilibrium should be shifted towards right. So in order to shift the reaction towards right, we need to remove time to time OH from the reaction mixture, so that reaction will proceed towards right. Number one. And number two type of reaction, if you use more and more ethanol in the reaction, we will get more and more ester. So two mechanism, 2 points will give you the maximum yield of ester. One is release of water from the reaction mixture, and other is use of ethyl alcohol in the reaction. Now, one of the very important things, hints is given in your textbook, and these questions very often appears. In place of ethanol, if you use methanol, again you will get ester. Here we got OC2H5. In this case, we will get CH3CO CH3. That process is called transesterification. 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 Mind that what is transesterification? In case of acetic acid, if you use methanol in case of ethanol in presence of concentrated sulfuric acid, the ester formed. The process to get the ester is called transesterification. Now, one of the tricky questions very often comes in your exams, also in entrance exams also, that alcohol, the type of alcohol which are used in esterification reaction, there are some reactivity. Which type of alcohol would react first to give ester? It is seen that 3 degree alcohol, 1 degree alcohol, then methanol is highest. It is top, first reactivity of alcohol in the process of esterification. 3 degree, highest methanol, then 1 degree, then 2 degree, then 3 degree. Now my question appears, how you come to know that methanol is the first, then 1 degree, then 2 degree, then 3 degree? I hope you know the degree of alcohol, 1 degree, 2 degree, 3 degree. So just you minutely follow one. Very beginning I told you that to get be well conversant with the organic chemistry, you must have some knowledge on the mechanism. So, just in a very short time, I am showing you what actually happens in the mechanism. So, if you recall, then we took acetic acid, ethanol, above the arrow, acid means proton, and we got the ester. Now I am going to tell you mechanism in short, as far as possible in a simplest manner. First, from acid we get proton, and that proton get attached here. That is called protonation. CH3C double bond OH, and OH remains same. 1, 2, 3 bond exceed of double bond. It is unstable plus, instantly it withdraws. We get CH3C OH. Whenever this bond is withdrawn, that carbon has got 1, 2, 3 valency, it has become plus. Okay, so I am rubbing off the first part, and what I get here is this. Now in the second part, what happens is CH3C plus OH, and we used ethanol. So write ethanol in this way. There is a lone pair here, ethanol. It is acting as a nucleophile. Lone pair attacks here, and finally you are getting what? CH3C OH. I have just taken it in the particle form, and O is here and H is here, and C2H. Don't get nervous with the mechanism. It is very simple. Very simple. Again you see oxygen has now bonded with the 3 bond. Now it has become plus. Then there is proton transfer. What's happened? Rearrangement, I think. CH3. I am rubbing off this part. CH3C O. That part comes here, and that will diminish this positive. OH2, OH, OC2, S5. I have aim to write the mechanism here. I have an aim to explain something, just to follow with patience. So you see, it comes out as proton. So you are getting, sorry, I am sorry, extremely sorry. This is becoming plus, am I right? Hydrogen 2 and 3 becoming plus, and there in this water is being removed. Am I right? So what you are getting is CH3C plus OC2H5OH. Am I right? Now finally that proton leaves out, and that bond comes in this way. You are getting C double bond O, C2H5. Is it not ester? So this is the mechanism. What is the main leading idea behind writing all this mechanism? The leading idea is that here alcohol, ethyl alcohol or 1 degree alcohol which used is attacking the carbon positive center of the reactant. Now if I make it second degree, CH2 CH3 OH, am I right? If you make it CH3, again if you make it CH3, so wherever you are increasing CH3, first one is 1 degree, second one when you replace one CH3 it was 2 degree, And third one finally when again we replace another hydrogen by CH3, it is 3 degree. So if you think 1 degree is free, there is little intervention of extending this lone pair to attack in the double bond. It is free to move. But when you make it one CH3, not this, it there due to the steric hindrance, bulkiness, there is a little problem occurs for this lone pair to attack on this one. When you use another CH3, CH3 means hydrogen, 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 like this, it encircles it. So this lone pair is not easily available to attack on this positive carbon. So the reaction will be fast only when this lone pair of alcohol is easily available, and that is found only in 1 degree alcohol. And when we transform in 2 degree or 3 degree alcohol, we find that bulkiness appears, steric hindrance appears. This lone pair is not easily available for attacking to the carbon positive center. That's why 3 degree is the least stable, then 2 degree, reactive, then 1 degree, then methanol. Another explanation is that it is a bit hard. From methanol, if you remove H, you are getting this part, and you are getting from ethanol CH3, CH2, OH negative part, again CH3 whole thing to CH, O negative part. If you think of nucleophilicity, it has got highest nucleophilicity. So if it is 1 degree, the nucleophilicity is the highest. That's why 1 degree will faster react, alcohol will faster react with carboxylic acid to get the ester. This is very important part of the reaction. So third part of the reaction is RC double bond O H involving with this CO. Mind to follow this one. It is we will use a reducing agent. We will use a reducing agent. Lithium aluminium hydride. We'll just use the reducing agent, then this part will just get reduced at CH2OH. Otherwise you can't understand. So again, if you in last class I told you, when there is oxidation there is removal of hydrogen, and when there is reduction there will be addition of hydrogen. If the oxidizing agent is strong, then 2 times hydrogen is added, H2, once H2 other times is removed. But when reduction occurs with the help of strong reducing agent like aluminium, if you get sodium borohydride, it will not do so. It can't reduce CH2 group, it is weak. So when with lithium aluminum hydroxide reducing agent, earlier oxidation hydrogen is added or removed 2 times. Now here in this case, hydrogen is adding 2 times. Simple way, if you understand this, if you use strong, CO becomes CH2, like Clemenson reduction, like Wolff-Kishner reduction, you got CO becomes CH2. In my aldehyde class, I will explain it elaborately. Now, I will take only 1 minute just to follow how it has come. This is not the mechanism, but the way or trick. C double bond, or earlier case I removed 2 hydrogen in oxidation, now I will add 2 hydrogen. Now what's happened here is addition of hydrogen, am I right? 1 hydrogen will attach to here, other with carbon, RCOH, and other with carbon, am I right? 2 hydrogen. So here water molecule comes, you are getting RC double bond OH. So 1 time you have added, you need another time. So again you are adding what? RC, 1 hydrogen with oxygen, other with carbon, and that hydrogen earlier attached. Are you not getting RCH2OH? RCH2OH. This is the way. Anyway, you keep it in your mind. If the oxidizing agent is weak, is mild, then it may stop on CHO. Okay? If it is strong, it will come to OH. So this is very important reduction. you try to keep it in your mind and try to know the reason how you are getting CO SCH2. Okay, so next type of reaction is for reaction involving very important question comes in this time NEET 2023 from this one. If minutely follow this one, uh, you will find reaction involving carboxylic group. This is very simple. You have got in first year RCOOH. If you remove carbon dioxide, what you are getting is nothing but alkane. The reaction is decarboxylation, the removal of COOH groups from the reaction, decarboxylation reactions. Again, another second type of reaction is that in carboxylic group RC double, you are better to write in this way CH3, C double bond O in hydrogen. In first type of reaction I told you hydrogen is get removed by sodium, so you add up one sodium, say plus and minus. Sodium acetate, very important reaction, this has come this time. What's happened here is sodium hydroxide and calcium oxide. This is soda lime. Soda lime, you keep it in your mind. Sometimes in the arrow above arrow it is given only soda lime. You are to write sodium hydroxide and calcium. You should know this. Am I right? So when soda lime is used and heated, what's happened? It is broken, not mechanism. It is broken. A simple H is get attached to this one. So are you not getting alkyl part? CH4 NO2CO3, NO2CO3. This time in entrance NEET 2023, in the reaction it is told, in the question it is told, the sodium acetate when get made to react with sodium hydroxide, calcium hydroxide and heated, a product A is formed. Find the molecular mass of that product when 2 times of that molecular product. Carbon is 12, 12 is 14, 14 to the answer is 30. That question was very simple, and you just follow the questions of NEET. You will find that each and every questions are arriving from the small textual question. You please go through the question textbook minutely and go up. After making your base strong, you will get each and every question from this book. Not a single one is out of this book. It's my assurance. So now, if I use formic acid, not acetic acid, sodium formate, and soda lime, what you are getting? Will you get now alkane? No. According to my rule, you just add there is one hydrogen. Am I right? Are you not getting hydrogen plus carbon dioxide? But like this, you are not getting any alkyl part. This is exception. Mind that this is exception. Sometimes questions are given in this way. Also, sometimes you are confused. Sodium benzoate, and you are getting sodium hydroxide. You are given sodium hydroxide, calcium hydroxide, and here you are asked. Just to break this bond here, you give here H. Nothing. It is benzene. Am I right? So these are simple. Just in the very beginning, I told you be careful about the reagent what is given above. And one type of reagent, when it is used, one same type of reactions will be in anywhere. So fifth type of reaction is with, I am writing here CH3, say CH2, C double bond OH, and I am using here in X2 red phosphorus, and number 2 in water. Mind that 1 and 1, 2 means first reaction is completed by adding up this and this 2. After completion of these 2, you give second. That is the meaning of 1 and 2. You don't give each and everything all the same time. You don't use all this reagent. Okay, first this let complete, then this. This is 1 and 1. In some reaction it is given Roman 1, Roman 2. This is the meaning. First use this one, wait for some time for completion, and then you use this. Don't use all this all alone. So here you are getting in alpha position CH3 CX, remove one X, to the X, X may be fluorine, chlorine and bromine, am I right? And this is COOH. At the very beginning, at first of this chapter, you are getting one name reaction here, that I have taken a carboxylic acid, there is alpha hydrogen, it is an essential thing, and using chlorine bromine in presence of red phosphorus. What is the use of this one? I will explain. And presence of with water, we are getting in alpha position halogen has introduced and getting this one, and this reaction was given by Hell-Bolhard-Janicki reaction. Bolhard-Janicki reaction. HBZ, Hell-Bolhard-Janicki reaction. Hell-Bolhard-Janicki reaction. And this is all about the reaction of carboxylic acid. One thing I will show you in my next class, RC double bond O R dash. It is ester. Reaction of ester with Grignard reagent and reaction of carboxylic acid with Grignard reagent. Very often these things are given, and normally these things are not given in books. Very often comes. Ester, reaction of ester with Grignard reagent and carboxylic acid Grignard. I will explain it in my next class. But last part of today's reaction is ring substitution. This is last. Ring substitution reaction. Ring substitution reaction. Say this is carboxylic acid. I am using here COOH, and they are concentrated H2SO4 and concentrated HNO3. It is known to you all in the first day you have got this is nitrating mixture. Out of this you are getting NO2. If I tell you how, today's class will be very lengthy. I will explain it. This is acid and this is base. Though both are acid, but here this will be acid, this will be base. OH, NO2 in terms of base, and HSO4H. Sulfuric acid can be written as like this, H2SO4, and nitric acid may be written as like this. Since it is acting as base, that should be OH will get attached with this one. You are getting HSO4 plus NO2 plus water. That is how we are getting NO2. And NO2 is very important. It is electrophile. In the benzene, maximum of electrophilic substitution reaction occurs, though in drastic conditions substitution reaction may occur. So whenever we see concentrated sulfuric acid and concentrated nitric acid, we will think that nitro means NO2 plus electrophile has come. Now question, in which position it will enter? Again this comes back to your knowledge of GOC. Carboxylic acid is like this. Here phenol deactivates. Phenol has minus I effect. One thing. And another time, you minutely follow this thing. In another time, when this withdraws electron minus this plus, this becomes plus, that plus it withdraws. Minus M effect. There is fight of minus I effect and minus M effect. But finally it is seen that minus M effect overpowers minus I effect. It wins over. So what's happened? It deactivates ring. How? When this bond withdraws here, this goes up here. Am I right? Now it has gone in this position, it is becoming plus. Now this part is coming here. I am not writing the above portion. Above portion will remain same. That part is going here and that remains in its position. This is becoming plus. That remain the same. Again this part comes here to help. You are getting, this is remaining in the same position, that is withdrawn here. Here you are getting plus and that position is remaining the same. Finally this comes this position and this comes in this position. This C double H. The fact is that in ortho and para position you are getting plus and plus. But mind that your electrophile was NO2 plus. Your electrophile was NO2 plus. Your electrophile was out of sulfuric acid and nitric acid, electrophile is this. Now this position and this position and this position has become electron deficient, that is plus. So plus will never prefer to enter in this and that, ortho and para position. So preferably it will enter in this position. So we are getting metanitrobenzoic acid. Thanks a lot for being with me and following my class with utmost patience. And in my next class, I am going to start a very new interesting thing. Along with, I have forgotten, one is protic solvent in my first class. Protic solvent and reaction of carboxylic acid with Grignard reagent, ester with Grignard reagent. Then with another more complicated and interesting thing I will. And today I have Ampelang effect. I told about Ampelang effect of in Grignard reagent, reversal of polarity, Ampelang effect. And next class I will protonic solvent and carboxylic acid, reaction of carboxylic acid or Grignard reagent, reactions of ester with Grignard reagents. A lot of question comes in entrance exams, also in the states. And I am winding up the today's lecture at this position.